Welcome back to the course on electronic packaging and manufacturing, and what we will do today is we will continue our discussion on first level packaging. If you recall, in the last lecture we had discussed about this interconnect technology called pin grid array. So, we had seen what a pin grid array is, and I had also shown you an example of a pin grid array as is shown here. This is the package or the substrate on which the pins are attached, right, and then this goes inside a socket like this, as we had seen the last time. Okay. The pins will perfectly fit in this socket which has corresponding holes. Okay. So, what we will do today is we will move on to some other types of packages. So, starting with something called the two that we are going to do today is called ball grid array and land grid array. Okay. So, this is the the concepts that will be covered today, ball grid array or BGA and land grid array or LGA. Okay. So, let us talk about each of these. The first starting with ball grid array. So, what is a ball grid array? Okay. So, we will spend a bit of time on this slide trying to understand what we are talking about. Okay. So, the first thing, if you look at the wordings, the ball grid array utilizes small solder balls for connection between the component and motherboard. Okay. So, unlike pins that we saw in pin grid array, here the interconnection or the connection with the motherboard is through solder balls. Okay. And there are of course different manufacturing methods and fabrication processes by which these balls are are put in place. But at this point, let us assume that the balls are there. It is possible to just have these solder balls positioned right at the places where these connections have to be taken out. Okay. So, therefore, instead of pins that we saw in pin grid array, we have solder balls that are connecting that are basically forming the connection between the corresponding points on the motherboard and on the chip carrier. Okay. Now, inside this, as you can see, the active chip that is connected to the package or the chip carrier by wire bonding. Okay. That is what you are seeing over here, right. I have also written over here that it can be connection can be to the package through wire bonding or flip chip technology. So, at this point, just hold on to what flip chip technology is, because that is something we are going to discuss maybe 2 lectures from now. Flip chip is a different technology, we are going to talk about that. So, at this point, just do not pay too much attention to that term, except that let it be there, because technically that is correct. Okay. So, what are we seeing here? We are seeing that we have this silicon. From the silicon, we have these points from which these connections need to be taken out, and that is done through wire bonding and connected to the leads or the connection points on the chip carrier, okay, which is also sometimes called the substrate, which we have used this chip carrier and substrate terms interchangeably. There is a little difference between the two, but for this point let us say this is basically the the substrate on which the microprocessor or the chip sits. Okay. Now, through the substrate, from the substrate, typically in pin grid array, or let us say in a dual inline package or in a quad flat pack package, we saw connections coming out from the periphery, right. But now, when we talked about area array packages, we said we are going to make use of the area under the substrate, and an example that we saw in the last class is pin grid array. But here what is done is, instead of pins coming out from the bottom of the substrate, we have these solder balls. Okay. You see these, if you look at the cross section, you see the solder balls, these blue circles, as you can see, and then this comes on the motherboard, and the motherboard will have corresponding solder pads. So, the balls are going to get connected on the corresponding solder pads, as is shown here by you see this dark blue lines over here, these are kind of the solder pads on the motherboard. Okay. So, this is how the connection is made. The other thing that you can see over here, which we are going to talk about later, but at this point you see some of these these lines that cut through the motherboard is called and denoted and named as thermal vias. So, these are thermal vias actually help in conduction of heat through the motherboard. I just want to make that passing comment here, because thermal vias are important, and we are going to discuss it more again when we come to thermal design. But thermal vias are very important because, as you can see, especially in this configuration, which is a plastic package. So, you can see a plastic molding on the top. So, the heat can only get transferred in the downward direction. Okay. So, it gets transferred through the substrate and then into the through the solder balls to the motherboard, and then through the motherboard to the bottom surface, from where you can either have an active thermal solution like a fan blowing air, or it will just get dissipated by natural convection. Okay. So, I wanted to spend this time on ball grid array just to explain that what is it that we are talking about. Okay. Now, if we go to the next slide, these are some pictures of ball grid arrays. Okay. Typically, Amkor, it is a company, I believe it used to be based out of Arizona in US. They may have shifted headquarters, I do not know right now, but Amkor makes these these chips and packages. And as you can see that here, these are many PBGA packages. So, BGA we just talked about, ball grid array, PBGA plastic ball grid array. So, this is a plastic ball grid array packages. So, from the top you will see it, I mean it will appear like this. So, this black or dark gray is the plastic molding compound, and on the bottom surface what we are going to see are these solder balls. Okay. There are certain specialized packages where the entire surface area can be used for solder balls, as is shown in this bottom corner, or you can see some packages where there is an area in the center that is left out. Okay. So, this kind of shows some pictures of BGA or ball grid array packages. Okay. Now, unfortunately, I do not have a ball grid array package to show you in this form, and can you tell me why? The reason is obvious, because ball grid array, it is a disadvantage that this, once you make this connection to the motherboard over here, the solder ball is connected to the solder pad on the motherboard, it cannot be removed, it is not detachable. It is not like a socket, pin socket arrangement as in a pin grid array. So, once it is connected, it is a permanent attach. So, whatever these pictures that you see here, especially on the bottom side or even here, these are before it is bonded to the motherboard. However, what I have with me is again a substrate where you can, it is difficult to see, but I will try to show you here. Okay. If the camera can zoom on me. So, again this is a motherboard, this is a piece of silicon, okay, and then this is the substrate. Okay. This little different green type is that is the substrate. Now, this substrate is bonded to this motherboard using a ball grid array, and if I just go, and as I said, I cannot remove it, I cannot move it out, and the reason is because it is permanent attach, it is soldered. But however, let me try to show you from the side, if you can probably see. If you really zoom in, you would be able to see the first row of solder balls between the underside of this above package and the motherboard. Okay. The other thing I want to tell you is over here, what you can see is there is a numbering on this side and there is also a numbering on this side, okay, and that denotes the position or the location of the solder ball. So, for example, on one side you have A, B, C, D, on the other side you have 1, 2, 3, 4. Okay. This is a little damaged package and that is why I have it with me because otherwise these are expensive. This was abused and damaged as you can see, but this kind of shows you that what is a ball grid array. And the ball grid array, as I said, is difficult right now for me to show you a package like I could show for pin grid, because that is a removable part, whereas ball grid array is permanent attach. Okay. So, what are the advantages of ball grid array? So, I have listed some of these and let us look at them one by one. Improved electrical performance due to shorter distance between the chip and solder balls. You could see right away from the package that I just showed the fact that this is a much thinner structure. Okay. The pins in a pin grid array is much taller, but however, in a ball grid array that is not the case. In a ball grid array the balls are of much shorter height, and as a result what happens is the electrical connections are much shorter. Okay. This improves the electrical performance because there is low resistance, there is shorter electrical paths, okay, compared to pins. The next thing is, because I could put thermal vias, this has a better thermal performance. Okay. So, because the solder ball directly forms a connection and forms a path for heat dissipation or heat transfer by conduction. All right. So, improve thermal performance by use of thermal vias that can be incorporated in the substrate. Okay. The other thing is the pitch between the solder balls, the requirement is much smaller compared to a pin grid array. So, therefore, it can have higher number of interconnects for a given area compared to a pin grid array. Okay. The other thing is, once it is attached, the handling related damages is less. In a pin, for example, if I take it, every time I take it out, put it in, etc., there is always the possibility of having some of these slender pins or delicate pins getting damaged. But in this one, once you bond it, because it is not removable, whereas it poses its own disadvantages, but the good thing is that it is a much more robust connection, in the sense now these connections, these solder balls are not subjected to typically not subjected to regular abusive handling, okay, which can lead to damage. Okay. The other thing which we are going to see later is when reflow attached to boards, the solder balls self align, leading to higher manufacturing yields. Now, what does this mean? What it means is, as I said before, so this is your package with the solder balls, right, and then you have a motherboard with what we call the solder pads, correct, and then there is by some way the solder ball has to be attached to the solder pad to form the connection, right. The way it is done is through something called a solder reflow oven, where the motherboard is put in the oven and the package with the solder balls, like what you see in this picture, the package with the solder ball is going to come and be placed accurately by robotic arm. It is called pick and place machines. It is possible to have it very precisely positioned and automated. Okay. So, once the package comes and falls on the motherboard, then this entire structure or this assembly goes through this reflow oven. At the reflow oven, it is heated to a particular temperature for a particular period of time, and it is very, very important to have this time temperature controlled in the oven. And when we do that, what happens is the solder ball just melts and forms a connection. And by the time it comes out of the oven and the temperature goes down, it resolidifies and the connection is made. Okay. So, this is how it is done. So, now what is happening, that in one shot, let us say this has 500 such interconnections on that package. What will happen? In one shot, all these 500 connections will take place. As the solder ball with the package flows through the oven, it melts and all the connections happen simultaneously. And then you can have a whole assembly line, a conveyor belt having many of these package on the motherboard, and each of them will get the connections made as it flows through the oven. So, this leads to very high manufacturing yields. Okay. The other thing, the self alignment of the solder ball, that is from a mechanics point of view and basically force balance. The solder balls, how does it form these perfectly shaped balls? They are not exactly spheres, because at the two ends there are connections, but they kind of self align and hold in place, hold themselves in place. Okay. And that happens because of the balance of forces, and surface tension does play a major role. Okay. Minimization of the surface energy. Okay. So, there is lot of research work that has happened on this one, on solder reflow, the self alignment, so on and so forth. Okay. But these are the advantages of the ball grid array. Let us just go through them one by one now that we have explained each point. Improved electrical performance, because the electrical path for transport of signals, electrical signals, is shorter. You can put thermal vias, and therefore, that forms a path for heat to get conducted. Okay. So, improved thermal performance. Now, the BGA, the solder balls can be very close to each other. Okay. The pitch requirement is smaller compared to a pin grid array, and therefore, for a given real estate, for a given surface area, you can accommodate more number of interconnects. Okay. Now, a disadvantage of ball grid arrays, it is a permanent attach, but it also protects it from any abusive handling. And finally, we just talked about the reflow process, which leads to high manufacturing, which can lead to high manufacturing yields. Okay. So, all good so far, but everything comes at a cost. So, everything cannot have only advantages. Okay. So, ball grid array also has its own disadvantages. Okay. And the first one is, it is difficult to inspect any deformed solder joint or any damaged solder joint inside. Okay. We sometimes can use an X-ray techniques, XRD and all that, but it is not very effective when we are talking about a lot of these solder balls, as is shown in this picture. Okay. It is very difficult to have, especially for the internal layers, a proper visualization, non-destructive visualization technique to see if the joint is actually formed or it has not formed. Okay. When we say if a joint is cold or wet, cold means the connection has not formed. Maybe while going through the reflow process, something happened, maybe there was some curvature on the board or the package, etc., for which this solder ball could not connect. It melted, but then it again solidified and the connection did not happen. There was a gap. Okay. There was a gap between the two. It should have touched, but it did not. Now, how do you inspect that? Very difficult. Let us look at this. If there is a defective solder joint inside, I just cannot make out, because this is all I can see. Even if I try my best, I can only see probably the first layers, nothing else, right. The X-ray techniques does let you go in, but again it is very difficult. Okay. So, solder joints does have a problem. The other problem I would say is that if any of these solder joints go bad or even this package goes bad, I have to throw away the entire chip, entire motherboard. Well, this is a test board with just this package on, but in an actual reality the motherboard contains many other equipments, many other components or packages. If one of the BGA packages go wrong, most likely you will have to throw it away. Okay. So, that is the problem of ball grid array packages, that is a drawback. I think I remember I told you an example that I had a very thin laptop, and these were all BGA attached. The problem what happened was, one day my display was not working, and when I took it to the repair shop, they just said that these are all ball grid array connections, and so you have to completely change the motherboard, and the cost of changing the motherboard along with all the other components was almost close to buying a new laptop. Okay. So, that was the problem. It is very difficult to rework these defects. Okay. So, that is what the ball grid array, the disadvantages are. The visualization is a problem, and if there is a defect you have to throw it out. Now, apart from X-ray there are some other techniques like fiber optic light, optical instruments, etc., but again they have all have their limitations. In other words, it does not give you the flexibility of a pin grid array or a connected type. Okay. So, that is the problem. So, today what we have learnt is about a new type of package known as the ball grid array packages. Okay. What it does is, the connections are, instead of pins, are through solder balls, and we saw a different pictures, different configurations, what is done and how it is made, the advantages and disadvantages. Okay. So, in the next class, we will wrap up this class right now or this lecture for now, and what we will do is, when we come to the next class, we are going to talk about another technique or another interconnect technology known as the land grid array, LGA. Okay. Thank you very much and see you in the next class.